So I have a little handout to put around here. It is glass, so please don't rub your finger along the edge of it, because a lot of people like to do that when they see glass. I don't know why. We've ground off the edges as best we could, but you can still cut yourself. So don't do that. So what I'm going to talk about is thin triple window research that we're doing here in the Windows group. Most of this I'm going to focus on why we're doing research on Windows, period. A little bit at the end I'll focus on why it's thin triple. So Windows in general, $25 billion a year through Windows in the US. It's about 4% of the total US energy is going basically out the windows, right? This is a big problem, and we need to find a solution, or at least to make this a little bit better. And if we look at that just at the envelope level, so this isn't including ventilation, what Ian's topic just talked about, but if you look at just the energy transfer through the envelope itself, windows are about, let me get a laser here, about 7% of the envelope area. So about 15 to 20% of the wall area, with the floors, ceilings, and everything. That's about 7% of your envelope area. About half the heat loss through your envelope is through the windows. And this is current codes. This is standard double pane, low E windows, what the code's requiring today. So windows are obviously a big problem in the envelope. So we need to figure out, what's going on here. And I think it makes sense to just kind of go through this in a little bit in a step-by-step way of why Windows, or how Windows become so bad in an envelope. So these are the current IECC standards. They're the climate zones. There really ends up being 3 different versions of this, which are highlighted in green here. Climate zone 1, which is the hot climates, the maps, well, it's kind of standing in front of it down here if you guys aren't familiar. That's a 2x4 wall with insulation. That's an R13 insulation. Most of the country, 3 through 5, is a 2x6 wall with insulation, or you could use a 2x4 and about 1 inch of foam on the outside. So that's what's standard now. In the coldest parts of the country, it's a 2x6 wall with 1 inch of foam, or you could use a 2x3 with a couple inches, or 2x4, sorry, with a couple inches of foam. So that's kind of the standard national energy codes now. And that's, if you just consider the heat transfer to the insulation, then of course it looks something like this. But we know a wall isn't insulation, right? There's a lot of parallel paths there. When you put in framing and your drywall, gypsum, your siding and all that, we drop down to what 25% framing factor is what I'm using here, which is pretty standard. So if we look at our climate zones, I'll maybe focus on that one. Your R20 insulation is actually about an R15 wall. And that's assuming you built it right, of course, and no air leakage and all those other problems, which I'm sure the folks that do wall research know that you're probably not even getting that. But that's really where you end up being. Now, if you stuck on a single pane window in that wall, this is where you are. You have an R1. And your wall, no matter how good your wall was, no matter what climate zone, you could have an R100 opaque envelope. You stick a 15% glazing area of a single pane window, you're about an R1 wall, right? So it's bad. So of course, code standards now, we don't use single pane windows anymore. But if you're looking to retrofit your house and you have single pane windows, and a lot of folks, in this area, we still have single pane windows. Say, I'm going to do a really good thing. I'm going to put good insulation in my walls and rebuild my walls, but I love my single pane windows. Think about this, right? So code standard today is the double pane low E window, and it's obviously much better. Our wall is somewhere in our climate zone, or somewhere about an R7 overall performance, so about half of what the opaque envelope ends up being. But we can do better than this, right? And I know everyone, I think somebody mentioned it earlier, the perfect solution, right? Here it is. Who wants this, right? Who wants to live in this house? Yeah. It's not plywood. This house is fancy. They use brick.
Just cover it with flat panel TVs.
Yeah, the LCD panel TVs. Right? Nobody wants to live in this. Mainly for comfort, view. People want to see outside. You want daylight. There's safety concerns, right? Egress in a lot of areas. You don't want something to have that. So that really isn't a solution, and we can find a better one. So the kind of easiest or most incremental approach or solution, it's not even a solution, but it's the next step along the way to help solve this problem, is triple pane windows. And you in our climate zone, that R7 wall becomes up to an R10. That's a pretty good improvement for a technology that's been around for a very long time, right? So if we think about trying to get the kind of whole US to the next level, we're trying to think of these incremental steps. And the good news is that if we can make triple panes today, so this is actually a data pull from the National Fenestration Rating Council, so anybody who makes a residential window has to certify their product. And so we can just pull the data off of that database and say, what can window manufacturers in the US build today? And it's about a quarter of the products certified are triple pane windows. So we know the manufacturers can do this. These have been in, this is from 2015 even. They've been able to do this for a very long time. But Windows sales, they're down here for triple pane. It depends on who does this research, but it's about 1 to 3% of Windows sales in the US are triple pane. It's almost insignificant. Most companies that do this research didn't even start counting triple pane until about 2010, 12, because they just didn't see the point. It was just such a low fraction of the Windows sold. So, why is the US having this issue? And that's one of the things that with our project that we've been working on is trying to figure out. This didn't come out quite the right colors, but that's all right. So we went out to industry. We look at the big home builders, right? The people that build most of the homes in the US. Why aren't you using triple pane windows, especially in the middle northern climates where we see it as comfort and other issues where we see it's a very valuable product to have? We get lots of kind of answers like, oh, they're too heavy. The window itself has to be too wide, and of course, when you had 2x4 frames, maybe, but 2x6, as we saw, is generally the standard now. In most places, that's not an issue. What it really comes down to when you talk to them for long enough, or you get them in a side room or at a bar or something, is that they're not required. Why are we going to use it? The code doesn't require this. And when it's not code required, that means it's a niche product and it's expensive. Window manufacturers don't want to change their lines. They are very efficient at making double pane windows. If you want to make a triple pane window, that means they're not making double pane windows, and that's going to add cost. And so they mark up the cost of these products a lot, way more than it costs for them to build them, especially if they were building these things in volume. And this, of course, is a cycle, right? If it's too expensive, the codes bodies look at this and they say, well, we can't mandate this because it's way too expensive to do. But the only reason it's way too expensive is because it's not mandated. So our project then is to, well, how can we start addressing this problem? And this is where the thin glass comes in. So all these questions about it being too heavy, too wide, too expensive, all their excuses. The idea behind this thin triple concept, have most people seen that piece of glass floating around by now?
Yeah, it's right here.
Yeah. So I guess this half has seen it, or has it gone over here? But the idea is you take your standard double pane IGU that you've insulated glass unit that you have today, and you stick a thin piece of glass right in the center. You add a second low E coating, so on this kind of what we call the fifth surface, or a second low E coating. And if you keep it at the same width of your traditional double pane units, you typically need to fill this with a different gas, a krypton gas. That's just to get through higher efficiencies. So what we call this is a drop-in replacement. And the idea is, so a window manufacturer, they don't want to change their lines. They don't want to change their frame or redesign a new frame or anything like that, right? So if you could have basically double that performance of the window part, or the glass part of your window, with a simple change to just the glass and not changing your frame at all, this is going to be significantly cheaper to their process, right? They can keep their flow the same, especially if they buy the IGUs from outside manufacturers, which a lot of these manufacturers do. They'll actually just buy them from an external company, bring them in, and put them into their windows. So that reduces their cost quite a bit. And of course, that means it's low entry costs. They don't need to buy new equipment for this. You can double the floors. And the last one there is minimal weight. And again, that goes back to using the same frames. You don't need a beefier frame, right? This weighs about the same as a standard product. So they don't need new hardware, beefier frames, all those other things that make these products more expensive. So why didn't we think of this sooner? And obviously, so Steve Selkowitz is sitting in the back of the room. Him and our team at Berkeley here actually did think of this sooner. In 1991, they filed a provisional patent on this idea. So it's been a concept that's been around for a very long time. You can see what that image looks like, this kind of center light floating here. The problem with this, of course, is it was way ahead of its time. Thin glass didn't exist. So to be able to do something like this, you would need to use plexiglass or something like that, which has its own inherent problems with being put inside of windows. So this really wasn't a viable product solution at that time. But we all know what half our desks are in front of us have these cell phones sitting on it with thin glass. That changed things, right? So when Corning and others now have come up with this thin glass for cell phones and now for big screen TVs, that changed things dramatically. So actually, 8 years ago or so, we looked at this project again and say, hey, now we think we have a chance. We have this thin glass exists. But Corning was the only manufacturer of that thin glass, and it was extremely expensive. So typical glass, 3mm glass, which is used throughout the residential window industry, for a manufacturer costs about 20 cents a square foot. They were being charged somewhere around $5 a square foot. And that's the manufacturer cost for this glass. Right? That's basically just makes it a non-starter. No one's going to bother doing this at those costs. But since this time in 2012, and this slide was made in 2017, there isn't only one supplier of this glass now. This is basically a commodity product. There's as much of this thin glass going into US houses today through TVs alone every year as there is of windows being installed into houses. So there's as much thin glass as normal glass going into our houses every year. So this really is a commodity product now. And if you look at this is 2017 prices, the costs have just gone down to less than $1 a square foot. Today they're even lower. In parallel to that, krypton gas, which we see it helps this performance boost quite a bit as well, used to be used in CFLs. Right? CFLs now don't exist, essentially. We've gone to LEDs, which basically took about or more than half of the market for krypton gas out of the picture. It's essentially pretty much only used in volume in windows now. And there's also been a demand for xenon gas, which is the kind of next gas on the table for satellite propulsion and other uses. So this krypton gas, the market has really fallen out of as well. So what you ended up being somewhere around $8 a square foot manufacturing cost when we looked at this project 10 years ago is below $1 now. And it's actually even lower than that in today's, when we look at it today. So now we see this as a viable product for the manufacturers to make. So then we have to address this, essentially why. It's not code required part of the equation, right? We kind of addressed the cost issue. The not code required part of the equation is a somewhat tougher one to deal with. And so we've been working actually quite a bit with the California, and it's funny, in a climate as mild as ours, to see as the best opportunity in the US to get triple-pane windows installed. It seems very counterintuitive, but we also have some of the best energy codes. And so when you look at it that way, you can start to see why that's happening. I'm not, I don't know the audience here that well, but are people fairly familiar with the California energy codes, residential side particularly? Maybe I see a few ups and a few sideways. Basically, essentially for a builder, they need to meet a EDR score. They need to build to an EDR down to a certain number. And they can there's a prescriptive path of how to do it. So these are some mandatory measures in the 2019 code, which just went into effect. High-performance walls, high-performance attics. These are mandatory measures that builders have to take. 0 builders take the mandatory or compliance path to build a building. All of them design their own building, and they do a compliance path, which is they just have to meet the same EDR score, and they do a simulation. And they say, I get the same score as if we did the mandatory measures. So every single builder does it that way, which gives you the opportunity to say, you can build any way you want as long as you can hit that score. So every builder, it's the game they play is they try to build this house as cheap as they possibly can do it. And they look at any potential measure to do it. And so what that means is now is that triple pane windows aren't really competing with double pane windows anymore to be put into a house. They're competing with a high performance wall or a high performance attic or quality installation or insulation installation, right? All these other measures that they could potentially do to get their EDR score down. That's what a triple pane window is competing against. And when you can get the cost down to the right level, and this is for thin triple or triple pane or any type of performance of, any way you build a window that gives that same performance of a triple pane, is you can see where those end up is somewhere this EDR is generally about 1.6 to 2.2, which is about the same as a high performance wall credit. So builders now, as an example, could actually still build with a 2x4 wall, and instead of switching to a 2x6 wall, but use triple pane windows, and they can get that same energy performance benefit. And so if they see that as a cheaper or better option for them, they're going to put in the windows. And to builders that build the lot lines, that is, and still use their 2x4 walls, that's a big deal, right? Because they can't go out anymore with a 2x6, they have to go in. And if you go in, the rooms don't work anymore. So you have to redo your plans and everything else. If all you have to do is switch out the window, that's a much easier solution. So this is a big opportunity that we see in California, and we're looking at Washington codes as well. They're about at the same level as this, where we're seeing the same trade-off opportunity. And we're starting to look at other states that are following these leads. So this is the kind of pathway that we're seeing for the high-performance windows getting into the market right now. And so California, again, leading the way. They're actually offering incentives to builders right now of about $6 a square foot of window that's going in to put in these triple pane windows. So builders, plus I guess they're $400 a square or per house. So essentially they're offering more incentive than the windows will cost them. So they would actually, for these demonstration projects, make a profit by putting in these windows. And the idea is to give home builders experience with these products to make sure that they're happy, that suppliers can actually get these products to them, the window manufacturers can, and that we can gain some insight into experience from the builders to make sure they don't actually see any difference in the installation. We've gotten I think our approach to this has gotten quite a bit of industry attention. This is kind of an old slide, but we've got quite a bit more. And I think that's good. There's awareness being brought to Windows that hasn't been brought for quite a long time. There's generally been this assumption that any window upgrade is always too expensive. But that's really not the case anymore when you start looking at these with the general energy codes getting cranked down to the level that they are now. So I think that's about it for me.
Actually, it's probably more like a comment. Just to underscore your cost aspect, I went looking for retrofit windows for my home 2 years ago, and went to like the local conference or whatever for home repair and stuff like that. And they were all trying to basically talk you out of going triple pane because they say, well, it's too expensive and it doesn't improve the R value that much and stuff like that. So that's one of the things I think you're going to be fighting more of too. And maybe that's changing already. I'm not sure. But the people who are selling the product seem to be downplaying it quite a bit.
Yeah, I had a window manufacturer salesman come into my house and try to downplay me on Windows too. It was more for fun that I just wanted to have him come in and hear what the salesman would say. Because it's always interesting to see how these products are sold, because it gives you, as a researcher, that, I clearly see the value in this, but what do people out there in the field see? So we're working, one of our biggest partners on this project is Andersen Windows, which is one of the largest window manufacturers in the US. And it was one of their sales representatives that came in and tried to downsell me. So I'm working with their research team on how to improve Windows while their salespeople are trying to downsell, right? And it's a huge problem. And so one of the, I didn't talk about it here, but so there's two real approaches that we see to this issue. The first is new construction markets, which is this mass market that we're trying to hit, which is the lowest dollar you can get, right? build the window the cheapest you can and get a performance level and get it out to the world. The other one is retrofit market, which a lot of these, and that's selling to the customer, not to a builder. And so the customer has a very different, or the homeowner has a very different value proposition, right? They're there for comfort. So our approach on that side of it is to really do we're doing a lot of comfort modeling and a lot of work with these manufacturers to show the value, so that they can go in and one of the things we're working on is they can go in and look at how much floor area of their house would be comfortable if they switched to the different window products, on a design day or a typical over the average of a year. So going to help salespeople, but also the homeowner make that choice, because they're much more willing to spend $2 to $3 a square foot. If their total window installation cost is $30,000, if it goes up to $35,000, that's more a value that if they can see the value of that, if their 30% more of their floor area is going to be comfortable and they can sit next to their window on a cold day without getting a blanket on top of them, they might be willing to spend that $5,000, right? So that's the approach we're taking with kind of direct or retrofit or direct to homeowner sales.
So I had a question on longevity of life cycle of glass. You got this thin layer of glass inside. I think a lot of us have experience with double pane windows. After a while, they lose their gas and get foggy, and you throw them out. Mm-hmm. But real old glass has a nice sag to it. What is the sag of that thin layer?
Yeah, so the sagging part of like leaded glass, that doesn't exist anymore. So float glass doesn't do. I mean, it does. It's still technically a fluid, but it's not doing that. It would be hundreds and hundreds of years before you would see something like that, like you see in old leaded glass windows. So yeah, that's not an issue. The issue of argon kind of leakage, I guess there's two. There's durability of a seal, and then there's kind of this gas leakage. The gas leakage issue has generally been solved by sealant manufacturers 20 years ago. So if you have older windows, there was, I think, a period about 20 years ago where the sealants weren't good, and then they fixed it. Now argon generally stays in the unit. Almost all windows sold now have argon in them, just by standard practice. That's part of their automated equipment. They just put it in. Krypton, there isn't as much data about it. From the sealant manufacturers tell us it's about their same performance, but you don't know. The other issue is just seal failure, and that's generally quality of window. If you buy the cheapest window you can buy, you might be more likely to have a sealant failure, just based on, because it might not be as good of a window. But the failure rates of some of the big manufacturers, the people that actually track this, the Cardinal IGs of the world, that are the biggest U.S. kind of residential glass or IGU manufacturer, they're very low failure rates.
Since the concept of triple panes goes back to early 90s, right? What kind of research is being done, say, on quadruple pane windows?
Sure. I was debating whether I should bring the quadruple pane sample as well in here of the same product. So yeah, I mean, there's quadruple pane gives you another incremental benefit. It's just as doable as this triple. And we have samples of it. And that's, as far as cost, is probably right now the best option to get to that level of performance. There's vacuum insulated glazing, which is kind of, I think, the most viable future technology that's out there. And by that, I mean it exists and it has for a long time. And manufacturers make it. You could go out and buy vacuum insulated glazing today, which gives you slightly better than triple pane performance. And if you make a hybrid, like a double pane window with one of the lights being vacuum, it's a little bit better than quadruple pane performance. But it's extremely expensive. The manufacturing just processes are very expensive right now. And again, if I put vacuum glazing in my own house. So if you've if you value that and you see it as something, and it's not obscenely expensive compared to other things you could do. I'm sure doing my whole house in vacuum was cheaper than putting in a granite countertop, I'm sure, in my kitchen. But I value that more than I value the other things. So, but as a commodity product, it's just too expensive right now.
All right, we got time for one more question.
So I have triple pane windows in my house, and I put them in 2006, and I can tell you they're heavy. But and they've been working. What I noticed though is what I think would be even better in terms of energy loss would be to have automated thermal shades that looked at heat transfer across it and had a smart controller. Have you done any work in that area?
Yeah, we've done quite a bit. So there's there's a lot of answers to that question. Yeah, so we have several test beds. You drove by one probably on the way up here today. It's right here on the. Well, let's talk. So we've done a lot of approaches to that. So one is, first of all, there has not been a standard for shading systems for a very long time. So the Attachment Energy Rating Council, exists now. We've been working on getting our software to be able to rate attachments for quite a while. And so if you're familiar with the National Fenestration Rating Council, NFRC, there's now a corollary, the Attachment Energy Rating Council, AERC. And so that project started about 5 years ago, but now there's products actually being certified. So that's kind of step one, right? Is so that you can have all these products on an equal ground. So as far as the automation part of it, we've done multiple projects on the automation part of it, and especially with commercial buildings and daylighting and glare and those sort of things. But on the residential side as well, we did a project 3 years ago with Pella Corporation, which is again one of the kind of top 5 residential window manufacturers in the U.S., and automating their between glass blind or between glass shade. It worked pretty well, I think. What we found, and generally, when you automate shading, especially if it's kind of energy efficient, if it's not external or it affects your view, I should say. When you automate something that affects your view, people don't like it. And because your daylighting will change, people generally just get upset about that sort of thing. And that's one of the, I think, really disappointing things we found out of that study that we did. We developed a really nice algorithm that saved the optimum amount of energy, and everyone hated it. So there's a lot of other ways you could do that, right? People can program it themselves. We had occupancy sensors on these, so we timed it to try to minimize the impact on occupants and all of these things. There's a lot you can do, and I think over time, those are going to get figured out by the shade manufacturers of what the best algorithms are, or if it's just programmable. But and generally we know if it's programmable, most people aren't going to do it. So there's right. Yeah. The approach that the AERC is taking right now for automated shading is to have that certification with their products is a programmable shading algorithm. So just a schedule based. You say at this time it's up, this time it's down. That's the approach they're going to take.
We appreciate it. Actually, now is a good time. Let's give him a round of applause. Yay.